So, first set of questions that you can be asked, just like before, what are the ions that will become discharged at each electrode? So let's set it up just like before. First question, what ions are discharged at each electrode? And you'll find that the questions follow the same type of pattern. There's only one variation, and we'll speak about that at another time. Alright? So, at the cathode, remember cations move to the cathode, so the copper is lower down the electrochemical series, so copper 2 plus ions are going to be discharged. Alright? And if they ask you what ions are discharged, most likely they will also ask you to write a half equation. Alright? So your half equation, remember your half equation is the equation that shows the movement of electrons. That's the only type of equation you will ever write where you have electrons in it. Okay, so your half equation, you're going to have copper 2 plus ions. How you get rid of the positive charge? You have to add a negative charge to it. How many negatives are you going to add? You're going to add 2 negatives to cancel out the 2 positive. The copper ions are aqueous, and you're going to get solid copper. Alright, so you get some solid copper. You may also be asked what is the redox process that is occurring at that electrode. Now, since you are adding electrons, think about your oil rig. Oxidation is loss, reduction is gain. So what redox process is occurring at that electrode, at your cathode? Reduction is occurring. Alright, so reduction is occurring at that electrode. Now, you can also be asked, what would you observe? What would you observe? Now think about it. You're forming solid copper. So what do you think you're going to see at your cathode? You're going to see a reddish brown or orange solid forming around the electrode. That is your freshly formed copper. As a matter of fact, freshly formed copper is actually quite pink, and then after a while it becomes reddish brown or orange. So if you don't remember the pink and you just say reddish brown, that's perfectly fine. Alright, or orange, that's fine. So what are you seeing? What's your observation? And all of this is happening at the cathode. Now, if you do for the cathode, you also have to do it for the anode. Or if you're asked about the cathode, you may be also asked about the anode. So we have to give it the same type of treatment. So, at our anode now, you had competition taking place between the sulfate and the hydroxide. Alright, and remember hydroxide is lower down the series, so the hydroxide ions are discharged. Again, you may be asked to write the half equation. Now, there are many things that I tell you that you have to know. I try to explain as much as possible to you so you don't have to memorize. This is one of the things that you will have to memorize. The only half equation that you will ever have to memorize is the hydroxide half equation. Why? Because it is written as 4OH minus, losing 4 electrons to give you 2H2O plus O2. So you have your 4 hydroxide ions, those are aqueous. They're losing 4 electrons or 4 moles of electrons to give you 2 moles of water plus oxygen gas. This half equation is something that you will have to commit to memory. I apologize, but you will have to commit it to memory. All the others you can kind of figure it out on your own, but this one is a little bit more involved. You'll have to know it. Alright? Now, since you see the hydroxide ions losing electrons, and you're losing because you're seeing a minus there, you know that the redox process is going to be oxidation. So if reduction is taking place at the cathode, oxidation has to be occurring at the anode. Alright? So that's your redox process. And what are you going to be seeing? Well, oxygen gas is being formed, and you know whenever a gas is produced, you see what? Effervescence. In this case, you're going to see bubbles of a gas. You're going to see effervescence of a colorless gas coming off around the anode. And then you can link up this now with your test for gases, and you could be asked for a potential test for how you would identify oxygen gas. And you know that oxygen gas reignites a glowing splint. Alright, so that's how you can make some linkages there with what you're doing. So your observation is going to be that effervescence of a colorless gas occurs. So none of this is new from what we did with electrolysis of molten electrolytes. Alright, go back and look at it again. Alright, you identify what ion is being discharged at each electrode. You identify what redox process is taking place. You write the half equation to show what is happening at each electrode, and you describe what you might potentially see at each electrode. For electrolysis of aqueous electrolytes, there's one other thing that you can be asked. One other thing, and that is, what are the potential changes in the electrolyte that you may detect? Or what changes would you observe? What changes would you observe in the electrolyte? Okay? In order to do that, you have to look at the ions that are being discharged. When an ion is discharged, that means it is coming out of the electrolyte. Okay? So, if we look at our cathode, our copper is being discharged, so we're getting rid of copper. Copper is coming out of the solution. Alright? And we're getting rid of the hydroxide. Hydroxide is coming out of the solution. Look at what we have left. If we get rid of copper, we get rid of hydroxide. We have H plus and SO4 2 minus. Those are the two ions that are present in That's right, sulfuric acid. So our electrolyte is going to become more acidic. Alright? And think about the color that's associated with copper, that nice pretty blue. The blue color of the electrolyte is going to fade until it becomes colorless, because we are removing copper ions from the electrolyte. So the last type of question you can be asked: what changes would you observe in the electrolyte? The blue color of the solution will fade. Blue color of the solution will fade, and the solution will become more acidic. And you can actually detect whether it will become more acidic by testing, whether with litmus paper or with universal indicator. Alright? The reason the blue color fades, remember, is because we are removing copper ions. The copper ions are becoming discharged and they are coming out of solution. And remember, the reason why it is becoming more acidic, we're removing copper ions, we're removing hydroxide ions. Alright? And what we are left with are hydrogen ions and sulfate ions. Alright, so the bulk of whatever is inside here is going to be hydrogen ions and sulfate ions, which is sulfuric acid. So that's the basics of electrolysis of aqueous electrolytes. Alright, it is not a difficult process. You just need to understand the fact that there is a competition taking place between two cations at the cathode, competition between two anions at the anode. You need to make sure that you know your electrochemical series so that you know which ion will get discharged when the process of electrolysis begins.